Saxon Advanced Mathematics, Lesson 54. Hello, students. Are you ready for a lesson that isn't too completely mind-blowingly nutty and not horribly long? I hope so. This one is fairly straightforward and kind of fun. All right, we're going to go back to the discussion we had not too long ago about the conic section. And if you remember, this is the sculpture made of butter that can be derived by taking, I'll show you with my marker how I make that work. Pretend this is a perfect line and pretend this is a perfect point, and I am rotating my line about that perfect point. Pretend all of this is perfect, right? The top and the bottom of my line, my marker, are drawing perfect circles, and we're capturing that full range of motion in a diagram. This is the diagram. Here's the point where my fingers were holding it. Here is one point where the line was. Here's the circle that was being drawn with the top. Here's the circle that was being drawn with the bottom. And then this shape represents all the different places that the marker was positioned as I was twisting it. Oh, pretend they all go through that center point, right? They all have to go through there. That creates a three-dimensional shape. A point and a line create this cool three-dimensional shape, and I have made a bunch of them out of butter, and I've given you guys hot knives so that you can cut through them. And we talked about how if you cut through here, and then you pick it up and look at it, you get a perfect circle, right? If you imagine it on a graph. If you cut it at more of an angle, you would get an oval, or what we call an ellipse. If you cut it like this, you would get a shape that looks like this, right? You would get two half circles, and that is called, why am I drawing a blank right now? That's called, weird, I can't even think. But that's not the one I want. I want this. I want a parabola. If you cut it so it just goes through one, and it would look like that, that's the one that we want. That is a parabola. Okay? So we're going to talk about parabolas today, and they always make this shape. Now, we've also seen them quite often because they are the graph of a quadratic equation, right? All right. And the classic one, excuse me, y equals x squared, looks like this, right? Oh, pretend it's perfect. That one's not perfect, right? And then if we did y equals minus x squared, that would give us that one, okay? So this is positive, this is negative. We're not going to do anything crazier. We could have them going side to side, or we could tilt them. No, we're not going to do that. In this course, we're only going to explore this and this, which are reflected in those two equations, okay? We are going to make them a little more complicated, but we're only going to go upward facing or downward facing, all right? Now, what's cool about these parabolas, let me flip, I don't want to get too crowded, is that if we write them in a specific form, they're very easy to graph. The form that we want to write them in is this. And we're going to talk about what all this means. The sign out here tells us which way it opens. Okay? If it's positive, it opens up. If it's negative, it opens down. This number here is called the axis of symmetry, and the sign is a part of it. But here's the trick. The sign is the opposite of this, right? Whatever the H value is, let me do that, okay? Whatever this value is, it's the opposite sign, okay? And I'll show you what these words mean. I realize you don't understand just yet. This is what we call the vertex okay? And this, the sign stays the same. I'm talking in the abstract. That's annoying. I think we did this before. I think we've covered this much, actually. So if we have something that looks like this, we can graph it quite easily. This is how we would graph it. We would say this is a downward dog. It's negative, so we know it's opening down. The axis of symmetry is -2. It's the opposite of that sign. And that tells us about the x-axis, right? So I'm going to put a dotted line along -2 because that is where our parabola is centered. Now the vertex is the high or the low point, and that has the same sign. So this means that it's at -3, and let's go 1, 2, 3. This is, if it was upward facing, then it would go up from there. This is downward facing, so it goes down from here. Okay, and then what we would do is a quick calculation to find one more point that's 2 units out this way or 2 units out that way. All right, I'm not going to do that right now because I just want you mostly to remember how this works. Now, the question is, what happens if we get an equation that we're supposed to graph? We know it's a parabola because it's a quadratic equation, but it's not in this form because this is the graphable form, right? But it doesn't always come that way. So how do we put it into this form when we want to? All right? And we are going to graph again, so don't worry if you still are like, wait, what is with the graphing? I'll show you again. Okay, but we're going to take it from the top. Example 54.1. Complete the square to graph y equals x squared minus 4x plus 2. Now, here's the thing. This is not in graphable form. To get it into graphable form, we're going to use the same process as we did to complete the square, which we learned last year, which we reviewed this year. Laura and Vivian, you were not with me last year, so my terminology and process might be a little different, but pay attention because some of the weird little things I'm going to say are very helpful in this process, okay? So here's what we do. We remember our steps for completing the square. Number 1, make sure this is in the proper order. Looks good. Number 2 is to kick. Remember, this is like ax squared plus bx plus c, right? Those are the names of these 3 terms. We want to kick c to the curb. What that means in this context is we're going to create parentheses for the a and the b terms. But then we're going to kick him outside. Before, when we completed the square, we subtracted and sent it to the other side of the equal sign. This time we're not doing that. He stays on this side of the equal sign, but he gets kicked out of the parentheses club. That's why I called it kicking it to the curb, because it isn't always going across the equal sign, but he's getting kicked out. He's just not loved. It's sad. Now we calculate the magic number, just like we did before. We take the b term, we divide it by 2, we put that in parentheses and we square it. We draw an arrow to the number inside the parentheses because that's important and we're going to need to use it later. This is our magic number. Minus 4 over 2 is negative 2 squared is 4. So we add 4. Now, before we used to say add 4 to both sides of the equation, right? But now we're on the same side of the equation. So if we want to add 4 here, in order to keep this equation in balance, we have to subtract 4 on the outside of the parentheses, right? Because if we add 4 and subtract 4 on the same side of the equation, let me put the y in, we're still in balance. This guy and this guy are harmonious to our balance. We have to add this 4 because it's the magic number that makes our perfect square here, but we have to subtract 4 to keep that in balance, all right? Okay, now we're ready to write this as a perfect square. We know that what goes in here is this number. That's why we draw the arrow. So it's going to be x minus 2 quantity squared. Now let's check that. That should mean that this number multiplied by itself equals that. Yes, minus 2 times minus 2 is plus 4. And it should add to this. Minus 2 more is minus 4. Okay, so that works. We write it with the square. And now, we summarize this on the outside. It's minus 2. Do you see what we did? We completed the square. We don't have to continue finishing that work. But what we've done is we've gotten this into the form we want, which is plus or minus x minus h squared plus k, right? This is the graphable form that we were looking for. So now we can stop right there. We don't have to keep going. This is what we want to graph. So I'm going to bring it down and write it again. Y equals quantity x minus 2 squared minus 2. So now we're ready to graph it. Ready? Oh my word. That's really crooked. Oh well, let's just pretend it's not. I'm going to put some of these guys in and we'll figure out what we need. Okay, this is obviously a plus out here, so it opens up. This number tells us the axis of symmetry. It's the line that goes right down the middle of the parabola. It's always on the x-axis, and it's the opposite sign, right? It's the opposite of that sign. It's that number, so it's plus 2. So I go to the plus 2 on the x-axis, and I draw myself a nice little thing there, okay? This number is what we call the vertex. It's the top or the bottom, depending on what our sign tells us. And it is on the y-axis, okay? So it's minus 2 on the y-axis. Because we're opening up, oh wait, I'm sorry, I'm not on my axis of symmetry. There. Now we're located right where we need to be, right? So now what I want to do is I want to find not a point that's 1 unit out, but a point that's 2 units out, just so I can figure out the basic shape of this. So what I do is I create a quick little table. I'm only going to create one value, but it helps me to choose the table. I'm going to choose an x value, and I'm going to plug it into this. X minus 2 quantity squared minus 2. Now, what do I want to choose for x? I want to go 2 units out from my axis of symmetry. Okay, so for my test point, I want to go 2 units out from axis of symmetry. So that means I'm at 2, right? This is 2. So I can use either 0 or 4, whichever calculation I think is going to be easier. So I'm going to choose 0, okay? So my calculation is 0 minus 2 quantity squared minus 2. 0 minus 2 is minus 2. Minus 2 squared is 4. 4 minus 2 is 2. So when my x value is 0, my y value will be 2. And here's the cool thing. The point on the other side of the parabola, if I go 2 units to the right, then I go up to 2. If I go 2 units to the left, I go to the very same place. And now I can draw my parabola with ease and accuracy. Final answer right there. How do you feel about it? It's not so bad, right? It's kind of fun. Let's do another one. And this is the last one. Complete the square to graph. Okay. Well, this is weird because we have all these minus signs. What are we going to do with that? Well, here's what we're going to do. We know that we want to kick him to the curb, right? So let's do that first. Let's put these guys inside their special exclusive little parentheses and let's kick him out. All right? Now that we have this, now I don't like those minus signs. So what we're going to do is we're going to factor them out. So we're going to write this as y equals minus the quantity x squared plus 6 with a gap. This minus sign we are not factoring out. This minus sign stays. We're only factoring out of those first two terms because we want to put it on the outside of the parentheses. He's not in the parentheses, so his minus sign is unaffected. Okay, now we've taken care of the minus sign. Now let's ignore it while we do our magic number calculation. We look at our b value. It's 6. We divide it by 2, and then we square it. We draw a number, an arrow there, because that's going to be helpful to us. 6 over 2 is 3. 3 squared is 9. So we're going to add 9 here. Now, are you ready to get your head blown? No, not your head blown, your mind. That's a whole different thing. Blowing your mind is different than blowing your head. I don't want any heads blown. We're adding 9 here, so that means we should subtract it here, right? Except, ready? This is the part. This positive 9 is affected by this minus sign. So what we actually did here was added minus 9. And so here what we need is a positive 9. What? Think about that for just a second, right? It looks like we're adding 9, but this is inside the quantity and it's affected by that minus sign. So what we're actually doing here is adding a minus 9. So to balance, we have to add a positive 9, and now the side is in harmony. Oh, that is so weird, right? Okay, let's write this as a perfect square, and then we'll combine those two. It's plus 1, right? This will be, I know this number is what I need. It's going to be x plus 3 quantity squared. This should multiply to that. 3 times 3 is 9, and it should add to that. 3 plus 3 is 6. Beautiful. We're now ready to graph. Ready? It's still crooked. Heaven help me. It's opening down. The axis of symmetry is minus 3. The sign is opposite. So my beautiful point will be there. The y, the vertex, is equal to positive 1. This sign is the same. This is the one that goes backwards. Y equals positive 1. So that means my vertex is there. I'm opening down. So it's going to be like that. Let's do a quick table and choose a point. It's going to be minus quantity x plus 3 squared plus 1. We want to choose the x value by either going this way 2 units or this way 2 units. Let's choose this way because then we can say x equals minus 1, right? I'm measuring from the axis of symmetry. I'm going 2 points this way or 2 points that way. 1 doesn't give us enough information. 2 is very helpful. So this is minus 3, right? So 1, 2 units, let's use -1. So now I'm going to plug that in. So minus quantity, -1 plus 3 squared, and then +1. All right, we go in here. -1 plus 3 is 2. 2 squared is 4. Then it's -4 plus 3. That's -3. That was a fairly confusing little calculation I did there. Let me write it out a little bit bigger. -1 plus 3 squared +1. Okay, that's plugging in the -1 for the x value. So first, I combined within the parentheses. That's 2. Then I squared. Right? The minus sign was underneath all that time. Then I took that off. -4 plus 1 is -3. That's how I got that value. That's confusing. Okay? So when my x is at -1, my y is at -3. So that's right there. This opens down. Okay? And I know that if 2 units this way, the value is -3. I know that 2 units that way, it's also -3. Because, how do I know that, you guys? Because parabolas are nothing if not beautifully symmetrical. And so if I go 2 units there, then I can go 2 units there. Oh, it's so pretty. Don't you feel happy with this? Okay, that's the right answer. And if I was grading this, I would grade probably 3 points on this and then 2 points over here. All right, we will definitely be talking about these in the video chat. I hope it makes a certain amount of sense. It'll get better, I promise. Thank you. Goodbye.